So the next cube is clearly simple cubic packing. That's this cube of square root of 2h. Since it contains only 8 spheres, that's these. We just have to stick what we have according to Pythagoras on the same size spheres and these drawings and the building blocks themselves and mathematics. Or should we bend the rules, bend the reality just to suit something so absurd and unusable, just to make Fuller original or unusually clever? Because our system agrees with Pythagoras, with spheres, and with the building blocks themselves. Our closed cubic pack is correct. Therefore, we know the 2.828427125 cube is a simple cubic packing. It cannot be anything else. The next cube is volume 8, that's this, H2. There is 8 of these small cubes in this one. Now here we have a rhombic hexahedra. Let me show that. Here we have a regular rhombic hexahedra. It's also made of 8 spheres, same size spheres. Here is a model with the blocks. This is a prime vector from center to center, same sphere, 8 spheres. And volume 2 cubes. So we know exactly where we stand. Here we have another structure which I can show. This one is a, let me also do it with the blocks, which is very easy with the same blocks. That's what's very powerful about this set, that we actually can demonstrate what we claim. So I just rearranged that regular rhombic hexahedra into square top and bottom based. Square on a top and a bottom, which these are half octahedrons, of course. But it's the same thing, it's an octet truss, basically. So we can connect the regular rhombic hexahedron with these, and we end up with the 60-degree coordinate system. And of course, we can do the same thing in here. We just connect how it was, like that. And we're going to have also the hexagonal closed cubic where face centered cubic lattice. We're going to have 12 around one, all at one same sphere. So we know where we stand in regards to the cube whose edge is square root of 2 and its volume is 2.828427125. Now let's do little mathematics. I'm going to show a small cube. This is the small cube. Has a regular tetrahedra in it. The volume of that regular tetrahedron is 0.33333333 times 6, since 6 is the lowest common denominator. Apparently that was discovered by me also, they had no clue. Since their lowest common denominator is 72, well, this is 6. And we know that 6 times 0.333333 equals 2 small cubes. Because the regular tet, this regular tet, is exactly twice the size of the smallest building block. And since 6 is the lowest common denominator, that's the result when using a regular tet as the unit volume. By the lowest common denominator method, always results in 2 cube volumes. So if this is a 2 cube volume, if we stretch it into a, if this would be a wireframe and you stretch it into a regular cube like this, its volume would be 2.828427125. So we have no doubt what we have according to sphere packing, building blocks, and the drawings, and the mathematics. So, just to finish this, the might, this is the might, it's exactly the same volume as the unit volume tetrahedron. Basically they are the same volume, and we see, as I said, that these blocks are, if they separated like this, they are half the size of the mite. Thus mite cannot be a minimal. Thank you.